Hello and welcome back to the channel. It's Mark from PowerSonic and Apprentice 121. Today we're going to have a look at installing this Proteus 30-way consumer unit. I've time-lapsed the whole install. I'm going to run through it and talk about the things I really like, some of the improvements that Proteus could maybe think about with these boards, and also some tips and tricks for the way I approach installing these bigger consumer units. So without further ado, let's dive into the time-lapse and see how this all came together. So we're going to start off with the meter tails going straight into this main switch. I'm just trying to get them to the same sort of length and shape, and then we can set those into the top of the main switch. I've slowed this time lapse down a bit from the last one that I did because a few people had said it went a little bit too fast. So I've run this at a slightly slower speed. You can see we've got a tails gland coming through onto this enclosure. It's a 40mm knockout on the side of this Proteus board. It's in just the right place to draw your tails through and drop them straight into that main switch. Is a contactum tails gland, and it's got the insert in there so you can secure your tails nice and tight so they're not going to wobble around inside the back of the board. And it's also got a little hole in there for your 16mm earth as well. I'm going to tuck that up right in the top and put a nice bend on it to set it into position. These only have so much give because of the size of them. You don't want them too tightly bent, just for pure aesthetics. So the main earth there is tucked up nicely in the top. Now this SPD from Proteus is a new product to market. It goes straight onto the bus bar. You can see that there. It's fastening down with no line fly lead, so you don't need to faff around with that. And it's also one less length of wire in the mix when we are worried about our cable lengths on our SPDs. And you can see in the top of here, I'm just going to drop the earth in as well and figure out the best route over for that, working to the set length that comes in the SPD kit from Proteus. So I'm just having to fashion a route through to try and dress this away as neatly as possible, sort of planning ahead for where I'm going to bring all my CPCs up as well, so it all sort of ties together nice in the end. And you can see I've dropped it up the middle there, popped a little loop in and roughly brought it into position. Now we do still need the neutral fly lead. You can, if you want, drop this down into the bottom of the main switch for this Proteus board. However, I'm going to take it up into the neutral bar. It's only a little bit of extra length on the cable overall, and I see that as a negligible issue, and it's just easier to wire up in this way with the neutral dropping out of the top. So just to interrupt the time lapse, you can see the new SPD from Proteus. This is a single module type 2. And it has an IN of 20 kA, it's got an IMAX of 40 kA, and the UP is 1.5 kilovolts. Goes straight onto the bus bar, as you can see there, so there's no line fly lead. In this case, I've just taken neutral fly lead up to the neutral bar. You could, if you wanted, take it into the neutral switch, because there's two terminals on these Proteus Ranger switches. So you've got the cage clamp in the back, screw head in the front. But I figured it's negligible impedance running through this large conductor up to the neutral bar, so it makes a little difference. It looks a little bit neater and tidier, and I know we're to try and keep these to the minimum length possible, but we're still well within the limits that were allowed for our SPDs, and I'm quite happy with that. Let's carry on with the time lapse and see how this all comes up in the end. So we can start to look at some of the final circuits now and get those dressed away. You'll note on the back of this board, it is a ply sheet, and I've cut out a shape that's slightly smaller than the openings into the back of this Proteus board. So we've not needed to use any grommet strip. You could still pop it in there for best practice, but the cables are going to go nowhere near it. So I'm not concerned about that whatsoever. And you can see I'm using the Nipex twin and earth stripping tool again that I demoed on the last consumer unit video we did, and I had a question as to if these would do 4mm. Now I don't think they're especially rated to go up to 4mm in truth. However, upon trying it, it cut it absolutely beautifully, so I'm happy to use it on 4mm. Whether it'll prolong the life of the tool in doing so, please do check the manufacturer's instructions before you try it yourself, but you can see there it opened it up nicely. It's not big enough for the 6mm in the top of this board here, so we're having to strip these the old school way by drawing the CPCs up the sheath to remove it. And again, just speaking about the layout of this board, at the top of the board I've gone for some of the high power consumption circuits. So we've got an EV, we've got an air source heat pump, there is an oven and a hob circuit, and also we have the battery storage system up there as well. So there's a few things of reasonable consumption that may all be running at similar times and for prolonged periods. So we're factoring that in and allowing a bit of spacing around the overcurrent protected devices. As I've mentioned before on the content, if you have those scenarios, then you do need to apply some derating factors unless you're allowing adequate space in between them for that heat to dissipate and not cause you a problem. So you can see there we've stripped off all those outer jackets down the top and the bottom rows, small power and the lighting circuits, and we're lucky enough to have 4mm radials on all of those power circuits. So we're now going to trim the ends of the CPC cables so we can slide the outer sleeving over, and this is one of the frustrations we have over in the mainland of the UK, where we still are popping in these sleeve-ins. I believe it's the same in Northern Ireland as well, but over in the Republic of Ireland, they have those CPCs sleeved in the final cable as it's provided to us from the manufacturers and wholesalers. So it'd be nice maybe to see that come to fruition over in the UK. I think the reason it's left unsleeved is if you have something penetrate through the cable, you're more likely to see an operation of an overcurrent protected device, and probably because it's cheaper. It's just easier for us as installers not to have to sleeve all these things up. It takes me about 5 minutes to work through these, but it is what it is. It's something that you have to do, and I'm just leaving these to a set length for the minute and putting plenty of sleeving on there so we know we're well covered when we start dressing these away. We're not faffing around individually sleeving stuff after we've bent it into shape. Basically, it's much easier, simpler and faster to pop your sleeving on while all those cables are straight, then work them away and take the offcuts out at the end. There shouldn't be much to cut away from these. I've kind of got them set to a length I know that works. This is a 30-way Proteus board, just to mention it, and you can see there is absolutely loads of space inside this. We have got lots of room behind the DIN rail to tuck our cables away, and we've also got lots of space around the side should you have cables coming in for, I don't know, an EV Ultra or something that you want to gland in, or a steel wire armor sub-main. There is so much room around these boards to do that. It is unreal, and we're very fortunate here with the layout, thanks to the spacing, to have even more room than perhaps would be otherwise if we were filling it with final circuits. And you can see with the CPCs on these circuits at the top, I'm just tucking those away, following the same path as that SPD fly lead. So we're going to have a nice, neat route for all of those CPCs up the centre of the consumer unit, and it just hides away nicely for a nice looking finished product at the end. And then we can tuck behind the DIN rail for our final circuits and just pop them back up over into the top as I've shown before, so we can loop them over into the top of the overcurrent protected devices, and they should form a consistent and nice loop at the end, hopefully, if it all comes together nicely. Well, I say that, I'm voicing it over, obviously I know it comes together reasonably well in the end. So spoiler alert there, as we watch this one through, you can see the CPCs getting dressed into the top there, and I'm leaving a spacing on all of these because, as I said, we're going to have spaces dropping along. There's individual spaces between the circuits on the right hand side, and then there's maybe 2 or 3 from memory where we space out just to separate across to the different entry points for the cables coming into the consumer unit. So running right to left, we've got the EV and the air source heat pump on the right hand side there, and over on the left we have got the oven, hob and battery storage system. And again, just setting a bit of space in so we can cover that off there. And these are 6mm twin and earth cables, so they have your 2.5mm CPCs. They're a little bit more rigid. The ends don't need bending over, even into the screw terminals, as opposed to a cage clamp, so you don't need to worry about that. You could still double them over if you wanted to, but you don't have to. And you can see here I'm just using my fingers and toes again to count these out and make sure I'm setting them into the right place. And I'm trying to leave enough length on these cables again, so if anyone has to do any adjustments or reworking, they've got something to play with. And equally, for somebody coming along to do the testing later on during an EICR, you can draw these cables forward, get your crocodile clips on and do whatever's needed without working with about 1mm of spare extra on the cable. You see, we're going to repeat the same process down the bottom. We'll start tucking these CPCs away underneath the DIN rail and dropping them back up centrally again to then draw out and loop into that earth bar. So these are split bars on these larger boards. So you've got an earth and a neutral bar in the top there, and then there's a linking wire that drops down, if you can see that on the neutral on the right hand side, into the neutral bar for the second row breakers, and equally the same again over on the left hand side for an earth cable that links up those earth bars, and the earth is also bolted through into the enclosure as well, so you've got double the connection, I guess, if you like. So we know we're adequately connected there, and the line drops off the main switch, if you can see that on the right hand side, and runs into the connector block for that bottom bus bar. And just to mention, those connector blocks are unique to Proteus. You can buy them separately if you want to. It's all available from CEF. So if you've got a wire that you want to take off the bus bar, for example, into, say, a fuse carrier and put it inside the enclosure, you can use one of those to make that connection and then use an appropriately sized cable to run off and do that. So you see with the CPCs, again, we're just drawing those up through the middle, tucking them up behind the top of that second row there, just to hide them away. And again, with the outer jackets on these twin and earth cables, we're just bringing them into the bottom of those openings. So we want to make sure we haven't got any single insulated cable outside of the consumer unit. And I am going to use putty pads on these to seal up the back openings. I'll show you that at the end of the video to prove I have actually got one. But it is just to seal the opening into the timber recess of this wall. It is a timber frame wall, and we don't want, in the worst circumstances, any fire that maybe starts within our consumer unit propagating out into the wider building. So it's important to make sure we do seal those openings up. And equally now tucking away those final circuits behind the DIN rail, so we can loop those up into the overcurrent protected devices, just the same as we have done up at the top. So again, on these bottom rows, we've got 1.5mm lighting cables over on the right hand side, and they're split down into a few different branches because obviously we've got quite a large install here, and we're just breaking the lighting banks up more for convenience in the event of a fault perhaps taking place, more than a requirement due to any load, because we're LED lighting. There's not a great deal of inrush current. It is just more losing less of the installation if there was such a time as a fault occurs. And that's often what we're faced with our max demand calculations when we're looking at these things with all of these overcurrent protective devices in the board. It can be more of a concern if you play that out by the old and very outdated calculations in the on-site guide. You'll often come to the conclusion that your installation is non-compliant. However, if you use some common sense, engineering judgment, and ideally some data logging, you can very easily see that you're in no danger of ever causing an issue in terms of maximum demand on most domestic installations. In fact, the consumption is generally much lower than many people expect, and Shavan Arnav put some great content out there that explains bits and pieces around that. You'll have noted me dressing those CPCs away into that bottom bar there, and with the 4mm, they have a 1.5mm CPC within those, so you do need to double the ends over on those, and you'll see I did that as I worked across that board. And we've got those now nicely dressed into position. I'm just dropping some cable ties on to help these form into a rigid shape. A little tip, if you are doing these consumer units, you don't want to be leaving your cable ties in place, but the sooner you get them on and nipped up, the better prospect you've got of having those form a nice shape when you cut them off at the end of your installation. If you leave it to the end and just pop your cable ties on for 5 minutes, it's very unlikely that the copper will remember and stay where you want it to stay after you set them free. So just pop those on there to allow those CPCs to set themselves into position, and we can now start working along with these RCBOs. So the top row is going to just be RCBOs because, as I said, these are high power appliances. There is an argument that you could get a benefit of some arc fault protection on much of the equipment within those final circuits. However, to the regulations as they are right now, it's not something that you need to factor in unless you was really wanting to. I guess you could make the argument that with the EV charge point that it has a socket on it, but these things have already been debated to death, and my view is that isn't the intent of that regulation. However, if you want to install an arc fault protected device on an EV charge point, you absolutely can do so. You can see there with the neutral fly lead, I'm just taking those around the back and dropping them down under the buzz bar, off to the side, ready to make them up into a neat solution at the end. I'll show you that when we get to that stage, but we're just tucking all of those up and around, leaving a space again in the terminal bar to allow for the spacing with those blanks. And these are the DIN rail mounted blanks from Proteus. They actually clip onto the buzz bar super duper tight to cover over those prongs and sit nice and flat onto the buzz bar itself. The line and neutral terminals in the top of these RCBOs are super duper deep compared to some of the other brands that are maybe out there where they seem to get shallower with every iteration that they produce. So a thumbs up there for Proteus for allowing a decent amount of wiring room inside the cage clamp. And you can see there, you just need to back these RCBOs off, drop them over the bus bar, and then they actually fasten onto the bus bar under that front screw, which gives a really solid connection and allows you to ensure that you're keeping your overcurrent protected devices square to the DIN rail and bus bar, so you don't see any of the lean and sag that you might experience with some other brands when you were using the cage clamp bus bar system. This is a much better solution when you are wanting to keep things square and straight. So it's starting to get a little bit full behind that DIN rail over on the left hand side, just due to looping back up and down. So we're having a little bit of a fish around to get that neutral fly lead drop down to the bottom, and then we can tuck that up the side again behind the tails into the neutral bar to allow for a nice connection. You'll see I've used washers in the back of this board, so these are just countersunk screws with a screw cap, I may add, on top of a washer. You can use panhead screws if you want and avoid the need for any washers and such. My own approach is to use the screw caps, washers and countersunk screws, each to their own on that front. And you can see again with the loops on the top of these, as I've shown before, I use a couple of fingers to just bend the ends over. If you grab the cables in the same place at the front of the protected device, when you cut it, they will all form a similar size loop when you put them together into the board, and it looks consistent, neat and tidy at the end. So it's just a case of making sure you're using whatever it is to set that distance. You could use a screwdriver or a bit of pipe or your fingers or whatever you like, and it'll just allow you to set that nice consistent loop. So again, with the fly lead, we're just tucking up and around the bottom there to try and allow to hide these cables away. Dress that last little circuit in at the top, and then we've got the top row all buttoned up and ready to just sort out the fly leads before we attack the bottom row. And it's coming together quite nice so far. I'm starting to believe in myself when we're at this stage that I might actually know what I'm doing, and it's looking reasonable up there. So again, with the fly leads, you want to make sure you've got them pulled down behind the back of the DIN rail so there's no extra slack sticking out of the top, and then just set a path back through to wherever you're tucking all of these away. And again, you can cut these to length and ferrule them if you wish, just to make it look even neater. My own view is to leave these as long as possible, so if you need to move anything about, you've got the prospect of being able to do that. And equally, if you take them out of the board altogether and want to use them somewhere else, you've not then cut the lead down and you've got the opportunity to reuse it if you wish. So you can see with these, I'm just tucking them up and under the top buzz bar, so they're out of the way, popping a few ties on, and again, we'll be cutting these off at the end. It's just to allow them to form a shape while we are setting the board out. Obviously, as I've mentioned, some of these circuits could potentially be under simultaneous and continuous overload, and if you've got no containment leading up to your distribution board and consumer unit, you will need to apply those grouping and derating factors if you were going to leave those cables tied together in bundles. So we don't want to have to do any of that, so we'll be cutting those off at the end. So we've got the buzz bar cover on there as well. That's a nice touch from Proteus. Some different manufacturers approach it with a clip-on cover to the buzz bar itself. I like the ones where you get a little clip cover into the buzz bar to hide it. It gives a bit of a space to hide some of those cables that you're trying to tuck away. You'll note there I hoovered out the bottom before we sat these final row of breakers in, just while there's access and space. It's something that sometimes you'll forget, and when you get to the end, it's harder to try and squeeze the hoover in and get out the swarf and the muck from the bottom there. Now, you'll note I was trying to get these clip-on DIN rail blanks into the right-hand side of the main switch, and at this bottom row, the DIN rail is a slightly different size. It's hard to describe, but it's deeper if you look to the left of the image compared to it on the right. And I think that's to account for if you're installing an SPD or whatever, it will clip onto the DIN rail in a different way, as opposed to the wider, fatter DIN rail over on the left. And as such, the blanking modules don't clip in. So we're going to have to use some different blanks over on that side. The front cover does come with the SPD blank plate in place. I've got this kit without SPD. You can buy it with an SPD built into the board ready off the shelf, or you can get it plain without one. And that's what I've gone for in this case, because I wanted to use and try the BUSBAR mounted SPD on this particular installation. So we've got those blanks on the front cover. I'll show you that later on. But we're just working our way through the bottom row now, much the same as the top. We're going to drop some cable down behind the DIN rail, loop it up and over, set your space, trim the ends and drop them into those cage clamps. And obviously we don't have to double these ends over because they're going into a cage clamp terminal. If you want to, you can do, but you don't have to. The connection should be suitably sound without, as long as you are stripping the appropriate lengths. You can see there, these are going next to each other. We're not using any spacing because these circuits aren't liable to be under simultaneous and continuous overload towards the maximum rated value of the overcurrent protected device. It's very low consumption lighting at the most, and we're not concerned with that in this application. So we can stack these up together just to enable things to look a little bit neater and also for ease of installation. We don't want to absolutely ram this board with so many spaces that you haven't got enough room to get all your breakers in, even when it's 30 ways. So you can see there, we're looping those over. They're starting to come together nice and neat. Again, with these, just dress them into a reasonable position that you're happy with while you are making this first set out. Don't get too tied to how the loops are all forming as you're working through the board, because you're going to have to run those fly leads and other bits and pieces around the place, and you will invariably knock those loops. So don't obsess over it too much, I guess is what I'm trying to say, while you're dressing your circuits away. Form the loop, get it set nice, roughly to the right height, and then move on to the next one, and you can tidy it all up at the end. So you can see there, we're now having a look at the last, I think it's the last RCBO to go in on this particular bank of circuits, before we move over to the power circuits, which are going to form some socket radial circuits in this case. So we've got some 4mm radials that are running out around the property, got a kitchen power circuit upstairs and downstairs, and as such, we are going to use some AFDDs. Now, the AFDDs from Proteus are of a generation that they are super confident and happy with, so they don't have any of this Bluetooth logging in and monitoring that David Savory so brilliantly demonstrated recently. It is very much off the shelf into the board, and it does its thing based on the initial configuration out of the factory. They've done lots of market research and updated the firmware many times of the past before they've launched their product, and they're really happy that it works. If there's ever an issue out on site, the Proteus team are very reactive to go out and view those issues themselves. They've been through those growing pains, and they're very confident and happy with their AFDD, and I've not had an issue installing them, and we've put a fair few in now. They seem pretty reliable and not nuisance tripping. I don't like that term. I don't think there's any such thing. Stuff trips for a reason. If it's oversensitive by design out of the packet because they've not seen whatever it is these ARC fault devices look for, it's not tripped for no reason. It's not a nuisance in that regard. However, it shouldn't perhaps be operating. So you can see with the AFDDs, they are a little bit taller, so there's a bit less wiring room. So we've dropped down to 1 finger spacing on these. And same principle, you just tuck it down behind the DIN rail, drop it behind the overcurrent protected device, loop up and in, and set those loops as neat and tidy as you possibly can. With the neutral fly leads on these, you'll note that I'm just sort of dropping them around the back and then pulling them out to one side for the time being. So my view was to try and form a little bundle of cables and hide them away over on the right hand side of this board, perhaps tuck them down behind the bus bar over on the right. So we're just making sure we've got adequate length on all of these cables to do that. And again, we've got the 3 AFDDs on all 3 of our socket circuits as required by the regulations. It says a recommendation, which apparently isn't something that BSI actually wanted in the regs by all accounts, but that's what it reads as. But that recommendation is a should, not a shall, but it is a should. So if you have got a socket circuit and you're not using AFDDs, you need to be going beyond what the regulations might otherwise achieve without them, is my interpretation of that. So we're starting to drop these AFDDs onto our socket circuits as standard. And you can see those loops, whilst less wiring room, significantly less if you look in the size comparison to the mini RCBOs, there is still plenty of room to form a nice bend on there. And we've just got the one final RCBO over at the end here for this final circuit, which is just a 4mm feed that's running out to a garage or garage. And that's just going to be on a traditional RCBO because there is other final circuits off that subboard down there. I did consider using a fuse on this, however we're running the twin and air through the fabric of the building. Didn't want to bring a steel wire armour back to the board, so we're putting the RCD protection on at this end. It's not going to be a huge inconvenience if that operates in advance of any other final MCBs within that garage board. Got the last few blanks on there, and we're just going to look at dressing all of these neutral fly leads away now. As I said, we're just going to swoop these over to the right hand side. We'll drop a few cable ties on again just to help things form into shape, and then we can set those free at the end of the installation. And again, just to say, this board will all be torqued down, tested, and those putty pads popped in over those openings in the back of the board. And we'll have a little chat about that at the end of the video as well. So I'm pretty happy with that. I think that's come up quite nice. It's taken maybe an hour and a half, I think, on this one. It's a little bit longer than when you're just doing a single row board, just because of the number of circuits you're dressing in more than anything else. And it is a little bit more faff with the overcurrent protected devices fly leads. It just takes time, doesn't it? The front cover goes on pretty nice for a dual row board, in fairness to Proteus. It was a little bit tight on one side, but it's just the blanks more than anything else. They don't screw onto the buzz bar, so they will move from side to side. But overall, that went on an absolute treat. No complaint there. They seem to have got that nailed down. The screws could be captive. There's an improvement. If anyone from Proteus is watching this video, that'd be a nice touch. But otherwise, I'm very happy with that board. I think it came up well. So I hope you've enjoyed the run through of installing this 30-way Proteus double stack consumer unit. There are loads of things I like about this. Lots of those I've mentioned through the course of the video. But just in summary, the RCBOs are bidirectional, they are also type A variety, and they open both poles, so the switch neutral, which is all important for those of you who are out there in the EV, PV and battery storage world, and we've got all of these extra considerations to tick off that maybe otherwise didn't apply in the past. There is lots of other manufacturers out there at the minute that don't have those important things in place, so this is where Proteus come out on top. For me, there's absolutely loads of room in here. They've got the brand new SPD that I've demonstrated again in here, which goes straight onto the buzz bar, saving us a bit of wiring inside the consumer unit and also a little bit of time. It's a simpler thing for consumers to understand rather than having an overcurrent protective device, and the SPD, it's all in one module with the single flag on there. So if there's an issue with it, it's simple for them to get some help to rectify. There's loads of entry points all around this enclosure. There's knockouts for your tails at the tops and bottoms on the side. There's 4 big knockouts in the back, and there are also some circular knockouts on the top with plenty of space to cut your holes in should you wish. This one didn't come supplied with grommet strip. I don't know if that was just a particular issue with the delivery on this. They usually do have a bit of grommet strip in there, so it could well be, or it could be a move that Proteus have taken away from supplying it with the board. And again, as I mentioned on the BG video I did before this one, it's a frustration of mine with grommet strip anyway. I don't like it, it's horrible stuff. And please, we need some entry plates for our cables on any opening that you may have in the back of your boards beyond a standard size that we can get from the wholesalers. So that's a little thing that Proteus could improve upon there. Equally, there is no gland for your cables coming into the main switch. That's something that they could look at. There has been a change on the screw fittings for the front cover. There used to be these clip-in variety, and I found that they popped out a fair bit. Thankfully, Proteus have upgraded that on this board already. They're the press fit threads, so you just screw it in and it's simple, easy peasy, and they don't pop out, which was a nice change to see. The DIN rail is super strong, it's very rigid. Your MCBs, RCBOs line up beautifully because there's no opportunity for the buzz bar to wobble and move about because it is fixed and secured in place, and it mounts unusually for lots of other consumer units on the market under the front screw head of those protective devices. It used to be the way it was done of the past, and then we moved to these cage clamp buzz bars. Proteus have gone back to this method. Well, I say gone back, it's always been the case in their boards for as long as I've been using them. So that's a nice feature. It allows us to get those set rock solid. There's plenty of length on the RCBO fly leads, which is super convenient on a large board like this. Although the terminal bars are reasonably close, you may end up with a longer wiring route than normal just due to the size. And it's nice to see that they've got it about right. And in fairness, as I mentioned on the BG video last week, lots of manufacturers seem to have finally nailed that down. I like to leave those cables long, as I've mentioned lots of times on content before, just in case it needs moving around in the board, or if it's going to go and be used somewhere else. You've not cut it to a set length, and you're just making work for yourself having to ferrule ends away, when often you can tuck these things out of sight and mind, as I did on this one, to not cause us a problem. Just to mention the Proteus mains tail switch as well, these are absolutely top of the game when it comes to your isolators. I've left the front cover loose so I can show you the terminals inside, and I did discuss it during the time lapse as well, I think. But you've got a part here that the meter fitters can put in place and kind of lock and seal, so they know we've got no access to it, and then there's a contractor's terminal. But the really nice thing about this is the twin screw heads onto that switch, and they're also an Allen key style screw head, so they're really useful for us to know we've got that tight torqued up connection we need, and that everything's safe and compliant for the customer. There is an improvement that Proteus could make just by utilising some of the other manufacturers in their range. They do actually own or as part of the same group as M2, and the M2 main switch, as I've shown on this channel when we've reviewed those boards before, has those twin terminals on the main switch. So just by combining some of the features within their existing range of stuff, they could improve this. I really like it. I'm very, very happy to install Proteus gear. The enclosure's rock solid, the breakers are ahead of the game. There are some tweaks that could be made to do with the labelling kit, and it's a similar frustration amongst all of the brands. I raised the issue with the BG board as well. There's just not the things on the label sheet that we're installing these days. So there's no PV, no EV, no SPD label, and no battery storage, and you're very limited on the number of lighting and circuits that are provided as well. And I guess that kind of harks back to installs of the past when these things weren't there, or we were installing fewer final circuits in an installation than we are now, when we're trying to subdivide a little bit more and install low power circuits and be a bit more bespoke and direct to a point of consumption than just putting large ring mains around people's homes. So that's something that needs to be looked at. It's no real issue for us out on site because we just use the label printer, and maybe that's something that's going to die away as time moves along, and these label kits will stop even coming with the boards, because at the minute it's a waste of paper because we don't use them. As I've said on the content, it's nice to try and put it into play and see if the manufacturers have got us covered, just in case we happen to forget the label printer the day we're installing these. The ARC fault protective devices are really solid and robust. They seem to be absolutely spot on in terms of their, we call it nuisance tripping, but there's no such thing in my mind. Stuff trips for a reason, but some ARC fault detectors were a little bit sensitive to things that maybe weren't at fault, and there was updates in firmware. And I know the Hager AFDD, as David Savoury has so keenly reviewed of late, that was an absolutely fantastic video showing how these things maybe don't operate when there are issues within a circuit. And I just watched one that he's done again today showing the fuse box AFDD, so it'd be interesting to see if he does any other brands on his bespoke test equipment that he's got in his lab at home. And it is interesting for us to observe of contractors, because we can't test these things, we don't know if they work or not. But having spoken to the Proteus team, they are very happy with the firmware that's in their AFDD. They go out to site and they've done analysis of the past already when there has been some problems on the first generations where things have cropped up, and ironed them out, and they are really, really confident in their product, which is nice to see. And I've not had a single issue with one as yet. But as I say, aside from some homebrew testing kit, there's nothing we can really do to say if they are functional or not. We're relying on the manufacturers to build that into the product standard. Build that to the product standard that dictates how these things should work, and we've just got to install them, and you know, the hope is that they do the job in the worst circumstances when they're needed. But anyway, we're waffling there. I hope you've enjoyed this content and the video I've put together again on a consumer unit. I'm going to try and do a few others where we just dress them away and compare the features. Just to mention again, this has got an intumescent pad that I've bought separately. Again, this is Proteus, and it's just a sheet of the putty that you can put over the large openings in the back of these boards where you've got cables coming through, should you wish to stop any prospect of a fire that originates inside the consumer unit getting out into the structure of this building. And this is a ply board that is onto a timber framed wall, so we want to make sure that's in place so there's nothing that's going to spill back into the building if there ever was a problem. And I'm going to get on with doing that now, along with the testing and all of the final talking down. If you've got any questions about this video and you want to get involved in the comments, please do so. If you've got any tips or tricks for me that I could try on the next consumer unit that I'm popping onto the wall, I am all ears for that as well. These things kind of evolve and develop in time, and my techniques certainly improved over the time since I put my first consumer unit in. And if you're on that journey, starting out in your career as an electrician or in training to be one, get some pictures of the work you're doing, share it online, and don't be afraid of feedback on your work, because lots of people just want to help you improve and share tips and tricks without being total trolls about it. Thank you for watching, and I'll see you on the next one.